Assalamualaikum and salam sejahtera. Welcome to our presentation. We would like to present about analyzing rubber industrial ecology for sustainable development.
Introduction for rubber industry. Industry ecology is an interdisciplinary field that examines industry system with the goal of optimizing resource as and minimizing environmental impact. It involves the study of material and energy flow through industrial system aiming to create closed loop process where waste from one process become an input for another mimicking natural ecosystem. Important in sustainable development for rubber industry is resource efficiency, waste reduction, emission control, lifestyle assessment, innovation and collaboration, and economic benefit. Rubber manufacturing encompasses production various products including tires, gaskets, cell, and industry components. Where these products are indispensable, traditional manufacturing methods have been associated with environmental concerns such as pollution, resource depletion, and energy consumption. Let's take a close look at some key ecological challenges in rubber manufacturing. For example, energy consumption, raw material use, waste generation, chemical use.
Let's see the literature review. Industrial ecology applies system thinking to industrial operation in an effort to maximize resources utilization and minimize environmental damage. The most important ideas in the rubber industry establishment are industrial symbiosis, life cycle assessment, and material flow analysis (MFA). Material flow analysis (MFA). MFA assesses inputs, outputs, and inventories to monitor material flow within a system and get insight into waste creation and resource utilization. MFA can be used in the rubber sector to track the consumption of raw materials such as natural rubber and synthetic rubber. Let's look the case study for MFA. An MFA conducted on Malaysian rubber industry highlighted inefficiency in rubber processing and demonstrated the opportunity of recycling rubber waste into new products such as rubberizer asphalt for road construction. Let's move on to the life cycle assessment (LCA). LCA analyzes a product's environment effects from extraction of raw materials through usage, disposal, and recycling. Utilization in the rubber sector is LCA can evaluate the environmental impact of rubber products like tires through analysis of emissions, energy consumption, and resource depletion throughout the course of their life cycle. For example is tire ecology. Tires are produced through various processes. Before being used or installed on a vehicle, when the tire is damaged or reached the end of its life, it will be discharged. Tires will be sent to derived fuel to be disposed of. Here, the tires will be processed into other products and will be recycled. It will repeat itself until the life of the tire is over. Therefore, no waste. The case study for LCA is LCA rubber in Europe discovered that the most significant environmental impact occurred during the usage stage because of fuel consumption. The finding prompted the creation of more energy efficient rubber design and better recycling procedure for end-of-life rubber. Last but not least is industrial symbiosis. Industrial symbiosis is the collaboration of industries to use each other's byproducts, waste and energy, and resulting in a closed-loop system. Rubber producers may work with other sectors to repurpose abandoned rubber or utilize it in products from other processes, reducing waste and resource consumption. The case study for industrial symbiosis is the Hellenberg symbiosis in Denmark is a well-known example for industrial symbiosis, where heat from waste steam and byproducts are transferred between several enterprises. A similar strategy has been applied in the rubber sector, where waste heat from the manufacturing process is used to power nearby operations, lowering overall energy use. By using this industrial ecology concept, The rubber business may improve sustainability, prevent environmental impact, and promote resource efficiency, that while additional harmonizing with large environmental and economic objectives.
Okay, we move the analysis. We have three analyses. First is resources use, second waste generation, and the third environment impact. Okay, the first in resources use is rubber sector waste on various additive and raw ingredient for rubber food production. It is exploring the use of secondary material resources like fat and oil residue to create modified tire retail, incorporating waste materials into new production cycle and reducing technology's environmental impact. The second is waste generation. The rubber sector faces significant waste generation due to the edgy, wear, rip, and scrap of rubber product. Improper disposal can lead to environmental issues and challenges in managing rubber scrap, increasing pollution and decreasing accessible space. Okay, the last is environment impact. Environment impact is rubber sector manufacturing process involves chemical and additive, causing environmental pollution. The supply chains disregard for environmental factor exacerbates the issue. Profit-driven production leads to inadequate waste management. Implementing green supply chains management can reduce pollution, as shown in is the nitrous oxide emission from ammonium sulfate use. The data is show magnesium sulfate production and so on. Okay, industrial ecology is a framework for rethinking industrial system to improve sustainability. This analysis aims to enhance a rubber factory's sustainability by implementing principles like industrial symbiosis, cradle to reincarnation production, and sustainable supply chain management, thereby optimizing material cycle and minimizing environmental impact. Is analysis for rubber factory sustainability. The first is the cradle to reincarnation productions philosophy emphasizes industrial ecology, aiming for safe, durable and economically recyclable products and ecologically sound process in rubber factory from raw material extraction to product disposal. And the second is sustainable supply chain management, integrating industrial ecology and symbiosis into supply chain management can significantly enhance environmental sustainability. Promoting cooperation between suppliers and consumer, therapy reducing waste and promoting continuous material use. And the third is industrial symbiosis. The rubber plant may be able to make use of leftover resources from other operations by forming industrial symbiosis with other industry. By doing this, waste is decreased and this for working resource in also decrease. You can see the industrial symbiosis.
Strategy and proposal to adopt a full circular economy model in the rubber industry. The following technique might be suggest is refuse, return, reduce, reuse, repair, refurbish, remanufacture, repurpose, recycle, and last recover. To adopt a full circular economy model in the rubber industry, the following procedure can be done is optimize production process, design for sustainability, raw material sourcing, energy efficiency. For promotion, recycling and reuse is first implement recycling and reuse programs Second, devulcanization and degradation method. 3. Ground rubber production. And last, energy recovery. Fostering industry symbiosis. First, collaboration and academic. Extended producer responsibility. EPR. Industrial partnership. And last, circular economy framework. Policy by granting tax breaks to business that use recycled rubber and by offering financial aid for investment in sustainable technologies. Government may encourage the adoption of circular economy practice in order to promote ecologically accepted alternative in the production of rubber. Policies should control the use of hazardous chemical and impose extended productors responsibility EPR throughout the entirety of a product life cycle. Second, technology. By making an investment in cutting-edge recycling techniques like devulcanization, rubber waste can be transformed into useful goods. Manufacturing is optimized, waste is decreased, and energy efficiency is raised via the use of automation and Industry 4.0 technologies. Furthermore, utilizing recycled rubber to create inventive items can expand market and accelerate the shift to circular economy. And last, stakeholder engagement. For rubber procedure, securing sustainable raw material procurement is essential. Material in charge and waste production can be facilitated via industrial symbiosis partnership, which other industries building trust will addressing social and environmental challenge is achieved via including NGO and local people in decision making. A sustainable organization culture is fostered via education staff member about sustainable activities and the concept of the circular economy.
These the challenges and solutions for the rubber factory. The first challenge is despite potential obstacles like high initial investment costs, competitiveness, price fluctuations, changing consumer taste, regulatory compliance, technological constraints, economic circumstances, and supply chain disruption. Implementing a rubber plant strategy can be challenging due to the high initial cost, market share, and changing consumer preference. And solution for rubber factory is to overcome challenges in the rubber industry. A comprehensive audit can identify areas for cost efficiency, such as labor and raw material switching, and implement lean manufacturing techniques. Market diversification can be achieved by expanding product lines and researching niche opportunity. Financial management can ensure sustainable growth by managing and minimizing cash flow. Employees training and development can be prioritized throughout and a secure workplace. Community engagement can foster strong bond with the community and promote diversity and inclusion. Technological upgrades such as digitalization and automation can increase productivity and improve product quality. Environmental sustainability can be achieved by adopting eco-friendly practices and technologies.
The conclusion is the rubber industry can significantly reduce its environmental footprint and improve resource efficiency by adopting a circular economy model. Collaborative efforts among stakeholders and investment in environmentally friendly technology can accelerate the transition to a greener and more sustainable future. That's all from us. Thank you for your attention.